Okay, welcome back everybody. In our last lecture, we talked about normal distribution and we briefly described the characteristics of normal distribution. The first one was that approximately 50% of the observations fall above and below the mean. The second one was that almost 6 to 8% of the observations fall within one standard deviation. The third one was 95% of the observations fall within two standard deviation, and the last one was approximately 99.7% of the observations fall within three standard deviation, and this whole thing is known as empirical rule. And sometimes empirical rule is recognized as 68 to 95 to 99.7% rule. Okay, this is important because we will be solving some problems based on this empirical rule. Since we covered the lecture in our last class, let's just do samples. Let's just work on some examples. Example. Test scores for a statistic for a statistic class are normally distributed. Normally distributed. I don't want to write the whole question, so I'm trying to find the shortcuts. Okay, so normally distributed with a mean of 100 and standard deviation of 15. So the question is asking us to use empirical rule. Use the empirical rule to answer what percent of students, what percent of students will have test scores. The part A is above 145 and part B is below 85. Okay, this is our question. Again, test scores for a statistic class are normally distributed, which is important, with a mean of 100 and standard deviation of 15. And use the empirical rule to answer what percent of students will have test score over 145 and below 85. So whenever we describe the normal distribution, we mentioned that normal distribution is classified by two parameters. The first one was the mean, which is mu, and the second one was the standard deviation, which is represented with a letter of sigma. So we need those two things to build a normal distribution. Okay, let me change the color, black. So do we know what mean is? Mean here is 100. So I put a check mark here, right? And the mean will be located approximately in the middle. And this is going to be 100. In fact, this could be a straight line too. Okay, and this is our mean. And do we know what standard deviation is? Yes, standard deviation is 15. So when we describe standard deviation is how far we are away from the mean. So if I go one standard deviation away from the mean to the right, the value here is going to be what? 115. How did I calculate that? 115 comes from mu plus sigma. Okay, so since this is symmetrical, I will go one step further from the mean to the other side. And 100 minus 15, 85. How did I calculate that? It's mu minus sigma. Okay, so that means I'm one standard deviation away from the mean here, and I'm one standard deviation away from the mean here too. Again, if this is something new to you, please go back to the previous lecture and understand what normal distribution is. Okay, based on the empirical rule, I know that one standard deviation is what? We said approximately 68% of the values fall within one standard deviation. So this area here is 68%, right? But since this is symmetrical, let me change the color. Let's make it orange. So 34% is going to be here. This is meant to be a this is meant to be a straight line, by the way. Okay. And 34% is going to be here. Okay. So this is a useful information. Let me change my color again. Let's make it green this time. So what happens if I go 2 standard deviation away from the mean? This is going to be what? 100 plus 2 standard deviation, and standard deviation is 15. So 100 plus 2 times 15, this is 130. So how did I get this number? It's mu plus 2 standard deviation. Again, since this is symmetrical, I will go 2 standard deviation away from the mean for the other side too. Okay, so this is what? Mu minus 2 standard deviation, and which is going to be 70. Again, this is mu minus 2 standard deviation. Okay, wait a second. I know the percentage of 2 standard deviation, right? So if I go 2 standard deviation here, do I know what this green area is? Yes, I do. It's 95%. Like the whole area here is 95%. Okay. 95% divided by 2. So this area is 47.5% and this area here is 47.5%. How did I get this number? Since this is symmetrical, 95 divided by 2, it will give me 47.5 for each side of the mean. Okay, so we said this is 2 sigma away from the mean, right? So this is 2 sigma. In fact, let me just use here. So this is 2 sigma here and 2 sigma here. Okay, very nice. So what happens if I go 3 standard deviation? Let's calculate that. Because based on the empirical rule, I can calculate my values for 3 standard deviation. So if I go 3 standard deviation from the mean is here, this is going to be what? 145. How did I find it? It's mu plus 3 sigma. And same thing for the other side. This is going to be 55. And this is mu minus 3 sigma. Okay, so we know that the distance from this red line to the middle, our mean value is 3 sigma. Let me use this. Okay, so 3 sigma, and I know that this area here on the left is what? It's going to be 99.7 over 2. And 99.7 over 2 is 4985. So that means 4985 for this area here. Okay, so this is 4985 here and 4985 here. Again, since this is symmetrical, 99.7 is divided by 2. And this area here in red is 99.7%. Okay, so is this going to be useful for my problem? Let's check it. So part A is asking, use the empirical rule to answer what percent of students will have test score over 145. So I'm looking at my graph right now. I'm looking at my normal distribution. So it appears that the question is asking me to find this area because it says above 145, right? It's asking me to calculate this area. Okay, how do I calculate that? Let me erase that for a second. So I know that the whole thing is 100%, right? This whole normal distribution is 100%. And I know that the area between those two red lines, which is here and here, is 99.7%. So let's subtract 100 minus 99.7% is 0.3%, which means this area here, these two tails, is 0.3%. But since this is symmetrical, I can basically take the 0.3% and divide it by 2, right? So 0.3% divided by 2 is 0.15%. So this area here is 0.15% and this area here is 0.15%. So that means my answer is 0.15% because it was asking me to calculate the area beyond 145. Again, let's explain this again. So the question was asking us to calculate the area over 145, which is this area. Since the whole normal distribution is 100%, and since the area between those two red lines, which is here and here, is 99.7%, I take the difference. The difference is 0.3%. So the remaining area is this and this. So these two areas, the accumulation of those two areas are equal to 0.3%. Since this is symmetrical, 0.3% divided by 2.15% for each side, for this side and for this side. And the question was asking us to calculate the area above 145, and our answer is 0.15. So this is what? This is part A. Let's do something about part B. Okay, part B below 85%. Oops, I didn't mean to. Wait a second. Okay, so I guess it's clear. Let me use a different color. I will use yellow this time. Okay, it says below 85. 85 is right here. So it's asking me to calculate this area. Okay, I guess that's easy. I know that this health portion is 50%, right? And wait a second, I know this difference is, right? And this difference is what? 34%. So 50 minus 34% will be equal to 16%, and 16% is my yellow area here. Okay, I hope it's clear. Again, I know that this health portion, the area below the mean, is 50%. And I know that this unsketched area, which is right here, is 34%. So if I take the difference between those two, this area, the remaining area, will be equal to 16%. Okay, so this is it for this specific subject. Let me know if you have any questions. I can do more problems on it, but I think it's very clear. But again, if you have any questions, let me know and we can work on more problems. The next topic is the z values, the use of the z values. Again, it's all about normal distributions again. I'll see you in the next lecture.